Thank you, Eric. Thank you very much. You and Rob, excellent job. Next slide, please. Tony and I will walk you through now confirming the effectiveness of the control system. A couple slides that Eric and Rob went through kind of show the different controls that are out there. In RM 13006, there's actually 9 that we are the most common, that we have case studies around. I invite you to read about that. So here we're going to look at elements 21 and 22 from APQP, and we're in phase 4. First one, if we can advance, is the initial process capability studies. RM 13006 has a lot of detail around how to conduct capability study, and especially when we're dealing with variable features, IDs, ODs, widths, lengths, and so forth. A lot of good case studies and instructions around what control charts to select as the control method. So Eric and Rob kind of went through the flow map that led to the PFMEA, that led to the assessment of risk. Risks are mitigated through controls. Now, they don't all have to be SPC related, but when a customer provides key characteristics on the drawing, we call those product key characteristics. And those are a fallout of the DFMEAs that are done, or FAMICA analysis, especially when determining flight safety related features. Generally speaking, those are asked to be controlled using statistical techniques to illustrate capability, but prior to that, stability, repeatability of a process. That's where 13,006 will come in. Below that, in 13145, we talk about dimensional and non-dimensional results. Every feature has to be accounted for somehow. And that's illustrated objectively on the first article inspection when we look at Form 3. And so those are accounted for in that manner. However, when we look at initial capability studies above, those are generally key characteristics coming from a drawing led by a design to build team and out of the PFMEA, where it's logical to implement process control techniques like SPC and apply capability studies for those types of features to reduce the risk of the process, not just the product and how things fit together. Next slide, please. So again, continuing with the flow and the flight path here, the control plan, second column to the, from the right is the control method. And it's that method that provides some type of a signal to the user of the method, generally the operator. We need to understand what is the signal that it provides that they need to react to. And that is the last column on that control plan. So the reaction plan and the control method go hand in hand. Those two columns have to talk to each other. In the production process run, we can see we're operating now in a mode of production with the input and output controls in place. And the controls, remember, controls are used to prevent causes of failure modes. Any cause can be controlled and corrected. And so process controls coming out of 13,006 are used for that purpose to prevent causes of failure modes. Especially in reducing the occurrence risk. Moving forward to the right, we may have a characteristic in yellow here identified as a key characteristic. That's going to have a certain control signature. we would be looking for SPC control charts, processes in control, the operator knowing how to respond to out of control patterns, understanding the Western electric rule patterns that illustrate non-random activity that requires us to take action. That's responding to the signal of the control. That's what's happening here. So there is a default validation around the use of SPC. Now above dimensional and non-dimensional results, there will be a default validation as well. It might be the use of first pass yield, defects per unit, some type of attribute measurement that tells us if things are operating well. And we'd be looking for evidence of compliance to those requirements. All of that would be in the PPAP. The initial capability studies, the MSA studies that support the measurement systems used to measure the key characteristic features. That's all built into the PPAP package and a lot more, obviously. So validation will tell us that the planned controls are good. There was a question that came up about inspection. And one common question is inspection a form of process control? This is a very kind of a debatable question. You know, one would say, well, the quality has already been made before you inspect it. Inspection, maybe it's an audit of the process controls put in place up to the point of that inspection. But I wouldn't go without inspection. I certainly would not, and I know you wouldn't either. So the validation of the control system from the prevention and detection columns of the PFMA in the form of the controls coming out of 13,006 to drive us to zero defects. Next slide, please. Okay, so at this point, I'd like to hand it off to my teammate, Tony Sweeting. Tony.
Hi, thanks, Pete. Okay, so it looks very complicated, this stuff. But the main thing this is trying to say on this one slide really is straight away, you try and build quality into it. And the best way to process control, the number one way, which was shown early on, and is a good example there of error proofing. We can't make something bad. So inspecting it would just confirm that I haven't done that. I haven't made something bad. So in terms of error proofing, if you can go that way, go that way. The next best way is, or the lovely table down the bottom, which is, well, let's find a way that we can check via process control. Is there a way of validating? And this could be on in terms of this, we're talking KCs, but it could be, again, mentioned in the chat. I noticed as I was looking, as we've been going through, that sometimes you choose them, and we'll mention that later on. But what would ever be useful for you to understand, is your process capable to make it rate, and will it always be that way? And will it always give you the right quality? And this table at the bottom, without going into too much detail, is what are the options? Do we have a variable, which is on the left-hand side in green, which is usually an easier one to understand in terms of trending and understanding if there is some subgrouping happening there. On the right-hand side is the attribute, mainly, is it a good or bad part? Defects per unit, defects per opportunity is sometimes used as well. So you have the choice. The choice there is, if you can find a way to remove the possibility of a bad part, an error being made, go for it. If not, find a way to control your process via other means. Controlling the inputs is obviously going to be a great one to make sure that you make a good pod again. But the cases that are checked to understand how much variation have I got in this first initial production run, what does it look like? Okay, so if we go on to the next slide, please. So here's an example, in essence, to sort of elaborate a little about the previous slide. Let's say we had a target of 75%, for instance. I mean, hopefully you would want more for your own sake in terms of rework or non-conformance. But if it was 75% in this case, we've got a number of batches and characteristics. So we've got lot 1, lot 2, and lot 3. You'll notice at the bottom left. Then we've got characteristics that are measured across the row. And at certain lots, certain points, when we measured these particular lots, we noticed we've got a good percentage, 80%, another 80%. But then we've got what could be unusual, but maybe in long-term production, it's the norm. You've got a 60%, actually lower. So when you average that out, you get something closer to 73%, which is not really what you're after. Never mind for the customer, but for yourself in terms of the pain it will cause, in terms of being able to predict what you're going to make and being able to plan your business in terms of inload as well, and buffer stock, for instance. If you did have that particular occurrence, the opportunity to consider temporary key characteristics. Generally, it's like a deeper dive. And if you can get into the point where it's a variable to understand, okay, I have 60%, what makes it different to the other lots of 1 and 2? What's the next step down, rather than just saying I've made bad pots? How could I use some variable data to maybe deeper dive on how it was made as well as what was made? So there's the opportunity there, and that's in the latest version of AS 13100. I'm sure Peter will correct me if I'm wrong, but chapter 9, I've been told that's the case. So that's where the temporary key characteristics may be really valuable to yourselves in terms of a deeper dive when you notice that something is quite right. And obviously, whenever you're looking at this, you're trying to choose lots or batches of work that are representative of your ongoing process. There's no point in picking the very best one if it's not going to be consistent going forward. Next slide, please. We've already seen this, but I'm just going to emphasize the one bit that Eric mentioned as well, which is 13,145 is the basis of what we're talking about. But it's augmented, and it's essential to look at the other manuals that we talk about, the other reference manuals. Here we're talking about 13,004 and 6 that are, they're integral to be able to use this. So while this has the broad structure to implement good SPC and to understand whether you've got a good foundation for your design, FMEA, etc., you should use the other documents. They all help each other. So don't use them in isolation. They are they're not mutually exclusive. They are meant to be used together as a greater whole to understand how we can make a better process and be predictable. And my last slide before I move on. Oh, thank you. Really simple slide, and it shouldn't be, necessary to say it, but sometimes we forget. Anything we learn via the actual process of using APQP or PPAP, we should feed that into what is happening in our process and the next new pots or new processes. It's great gold dust of data that we've had to collate, maybe because the customers asked for it, but it's useful for ourselves to understand, okay, we had to do this last time to pass a validation and to understand the process. That's a good bit of a starting block to go off to understand what we can do with that data. And like any good PFMEAs, they're live documents, and you constantly fill them as you go in your process to go, are we better or worse than what we initially thought as well? So it's a live document.